With the power of scripting, you can do almost anything you want in DaVinci Resolve automatically. I've made scripts that add modifiers to controls. I've made a script for jQuip that allows you to resave macros. I'm working out a brand new way to make macros themselves with my new macro creator, and many, many more. The power of scripting is unmatched. So let's get learning it. Before we start, I do want to mention I do have a burn on my forehead and on my arms, so if I look a little bit more lobstery than usual, then that's probably why. Before we start, remember you do have to have your own text editing software. I like VS Code. You can obviously choose something like Notepad++. I'm going to go ahead and do Control-N for a new file, and we're going to go ahead and save this into our scripts folder. The way we do that is come down here to your search bar, type in %appdata%, brings you into your roaming folder, go into Blackmagic Design, DaVinci Resolve, Support, Fusion, and this is where all of your templates, presets, scripts, fuses, everything that is community made will go. What we want to find is our scripts folder, so we're going to go ahead and go into scripts, go into utility, because utility usually shows up at the very top of the list, and save it to that folder. So we're going to go ahead and copy this file path now and paste it up into here. Pressing enter. I'm going to go ahead and name this just tutorial project, and we're going to change the file type to a .lua. So to start us, we're going to be talking about variables. These are words or letters or a collection of characters that are assigned to either a string, a boolean, or a number. And what those are is we have a string, we have a number, and we have a boolean. A string is going to have any parentheses around it. You could have regular parentheses, or you can have the single parentheses. Both of them work just fine, but some of them have different situations where one is better over the other. And we'll get to that when that happens. We also have numbers. These can be integers, or they can be decibels. It can be really whatever you want. We also have booleans. Booleans just mean true or false. There's nothing really else to it, but false also means nil in certain cases, which nil means none. If you haven't experienced that before, if you're brand new to coding in general, that may not mean a lot to you, but we will break down what that means when the time comes to use that. By default, all variables are global variables, which means that they will be accessed anywhere outside of any if statements or any other pieces of code that you would usually think of as having only local variables. Everything by default is global, but everything global expects a capital letter for the first letter. So right here, it expects this to be global because it expects that capital letter. However, these two it will be confused about because it thinks that these are meant to be local because they're not capitalized. And we can fix that easily by just either typing local in here or doing underscore, capital G, and then period to let the code know this is meant to be global, so act as if it is meant to be global. You can also reference other variables. All you have to do is make it equals to that variable, and if you can also check if that variable is nil or not, so if it doesn't exist or not, by doing or, you can put another option of what that could be. We know that variable is a string variable, so we want to make sure that it's either that or it's a different string. And then variables can also be a call for a table. So a table is a collection of things within a parenthesis. These can be anything from numbers to booleans to strings, even other tables. And then inside of that, we can have even more tables. And tables are very special because they still need to either be called as a local or global, because tables can be either just in that local area or in the global space. But tables cannot be printed normally. So if we just printed a table, we go back to DaVinci Resolve and actually just test print this real quick. So we come up here to Workspace, come down here to Console, and this is where we can see all of our print statements that are going to be printing. So come up here, go down to Scripts, and look for whatever project you just called it. So we're looking for a tutorial project. We can go ahead and click that and run it. And we can see that we printed just a table index. This is essentially like the ID or UUID, the unique identifier for the table. So to see individual parts of it, we can type in bracket and then 1 through however many numbers there are in this table. So if we type in 1, this is going to give us the first slot in the table, so it's going to give us 1. If this was 2, this would give us our boolean right here, false, and then it would, 3 would be string, and so on. So if we run 2 right now, it's going to give us false. There are also other ways to write tables. There's something called a complex table. Now, I don't know if this is actually its actual name, but it's what I tend to call it because it is a bit more complex than a regular table. What it is it's still using brackets, but we can make it a little more formatted here to make it easier to tell what's going on. And we can just type in an item name and then give it some classification. So we can give item 2, and we're going to make this one a string, and then we're going to make item 3 and make it a Boolean. And you cannot print this one the same way because you actually need the ID, which is the name in this instance. It's not just a number. This is the ID of these positions, and we would go 1, 2, 3, 4. These are now the IDs of these items. So to get these items in calling them back, we would have to figure out what these are called. So if you make the table, then that's great. You can easily make something that will just read out what each thing is that is in each section. So we could say print complex table at the ID of item 1. It would give us 10. If we try to give it the ID of just 1, it's going to be confused. It's going to give us nil because nothing has the number 1 as its ID. However, what if we want to read the entire thing? Well, it's also pretty easy to do, but we can't, as you saw before, print it with just trying to print the variable of the table. And in Lua, there are built-in string systems or conversion systems in general that can convert either a number to a string to a Boolean, and all that kind of stuff. What we can do is we can write to string in here, and what we can do with this is print this now, and it's converted the table to a string, right? And correct, we are still getting table ID. We're not getting the actual table itself. What we have to do instead of writing to string is we have to look at the BMD, Blackmagic Design, whole index of commands we can do. And we can show you that in a future video. But for now, all we really have to focus on is having bmd.writeString and putting the string in the parentheses here. And then this is actually going to dump, essentially, the contents of that table, just like that. So instead of actually seeing either just one part of the table or seeing just the table ID, this dumps the actual table so you can easily tell what's going wrong with your tables. Next up, we're looking at if statements. If statements come in a couple different forms, but only really do one simple idea. So for our example here, we're going to check to see if reference variable is equal to all, which is by its default variable name or string. And then we're going to say if it is equal to all, then we're going to do something else. And in that case, we're going to print the word all in all caps. And then we're going to say else if, because if is a comparison column. So you are going to compare one thing versus another with either equals to signs put side by side, just like this. We can also do greater than or equals to, less than or equals to, or not equals to, which we'll get into all those here in a second. But we can then, after our regular if statement, we can then do an else if, which is adding on to our if statement, do another if statement right after that. We're going to check to see if reference variable is equal to none instead. And then if it is, we're going to print, and then we're going to have one more check just for anything else. And then we're just going to type in error as the print for that one. And then at the very end, we just have to put an end so we can tell the if statement to stop looking for other commands. There we go. Let's go ahead and run that and see what that gives us. It should give us all in all capital. And if you run it, that's exactly what it gives us. Perfect. Heading back to here, like I mentioned before, we also can do greater than or less than statements. So what we can do is do if also a variable is greater than 20, then we're going to print big. And we're going to check else if also a variable is less than or equal to 5. Then we're going to print small, and then going to call that end. So this is going to check to see if this variable up here, this number is either greater than 20 or if it is less than or equal to 5. At the moment it is 10, so it's neither of those, so we actually shouldn't get any output from this if statement. If we come into here and run this now, we can see no print has happened from that if statement. And there's one more thing I want to show you just so you can know everything possible about if statements. There might be a few things that I'm not remembering to teach about, but this is also very, very important. We can also check if a variable is a nil statement or is empty. There's nothing inside of it, which is still nil. Nil basically means none or nothing, empty, nada. What we can do is we can check if not still a variable, then print. Both of these are ways to check if something is nil or false. We can also type in nil here, and this would give us the exact same response. If we type in false, it is fine, but if we look back, still a variable is a Boolean. So checking if false may be more accurate here, but you can do this with any other variable possible, and it will still check the same thing. It will check if it exists. And there are certain cases where it is possible for a variable to not exist yet, especially if we're getting user input. Next up, we have for loop. For loops and loops in general are a fantastic way to iterate over something multiple times, to either make sure you get everything, or to go through a list, or any other amounts of reasons. The most basic way of using a for loop, however, is doing for. Any variable either can be a single word, can be a single letter, can not be a number, but it can be anything like that. And we can set this equal to a small number like 0 or 1. We'll do 0. And we want it to count up to 10. So we're going to loop through it 10 times. And we want it to count up in single integer steps. And then we're going to say do. We're going to type an end so it can end it out. And then in this loop, what do we want it to do? We want it to print I. And printing I is local to this for loop. Only inside of here can you actually access this I variable. When we print it, it's going to give us the number that the loop is currently on. So if we were to go to run this now, we can see it counting from 0 up to 10. Real quick though, I do want to show you, you can do it in the reverse. So if you set your I to 0, and then actually make your 10 a negative and make your 1 a negative, if we were to print this, we're going to see it actually is going to be counting down to negative 10. And this is just the beginning of what for loops can do, because we can also iterate through tables built into our for loop. So we still have our number that we're going to have as our index. This is the number that we're going to be at in our loop. And we can assign this with either a variable with like a letter or a word, or we can give it a straight up underscore to let us know in the future and to let the code know this is a variable that we're not going to actually be using at all in our code. So we can go ahead and make that underscore so it's not going to even matter. Then we can do I in I pairs and put in a table. Then we're going to say do all this stuff. So in this case, we want to check through everything in our table variable. So everything in this variable here. We want to check through everything. And if we look, we have a table sitting in here. So we want to make sure, remember that we can't print what a table is, and we want to print all the items inside of this table. So if we can't print a table that's inside of the table, what do we have to do? Well, what we have to do is figure out if it is a table, this current spot in our loop. If our current spot in the loop is a table, then check through everything inside of it, just like how we're doing right now, and then print all that stuff. What iPairs does is it's going to go through our table in order that we've created it or things have been put into it, and it's going to go through it one by one and then assign each individual part of our table as I. And then the index, the number spot that we're in our table, is going to be this unused variable. So to check to see if what we're dealing with is a table, all we have to do is type if type of I, so of our current part of our table, is not equal to table, then we're going to do something else. So we're going to just print I if it is not a table. So if it's anything besides a table, it's going to print. So if it's a Boolean, if it's a string, if it's a number, it's going to print. And we're also going to do else, and this is going to be if it is a table, then we're going to do this. And we're just going to do another for loop, just like how we already have it, where there's nothing for the first variable, and with this one we're just going to make it v because it doesn't matter, and then in I pairs again, and then we're going to be doing it for I because we know it's a table in this case. We're going to do, and in this case we're going to print I. This right here is only going through the first table, and it's then finding the second table, and then it's going through it and printing the objects of that table. So if we were to run this in DaVinci, we're going to see it's going to end in tables. I accidentally printed I instead of V, so we can change this to V now. And now it should work for us. We should see that we should only see one extra table that's not being printed because we have not broken that one down yet, just like that. And in the future, when we're talking about our functions, I'm going to be showing you how to do like a recursive, repetitive function that allows you to go through any amounts of nested tables inside of any other table. Continue now on to while loops. So while loops are very similar to for loops, but I feel like they have slightly less uses than a for loop does. But let me go ahead and show you them. They're a little bit less used, but they're also still good to know for certain situations, like this first one. So first, let's actually make a variable, and we're just going to assign this to 0, and we're going to say while true, do, and then we're going to give it the action to do. So we're going to say to print v, and to add a single number to v each time we run the loop. And then we're going to check if v is equal to 10, then we're going to break out of that loop by literally calling break. And that's just going to tell the while loop, hey, it's done, we're good to stop this. And you can run this whenever anything happens while you're looping through. So if we were to run this, it's going to be going from number 0 up to 10, right? Actually, weirdly, no. It's only going up to 9. And I don't know why. I think something is a little limited, has a limitation with how I'm doing that piece of my code. You can maybe mess around with that and let me know if you can figure out how to make that work for you. And we can also do while loops in a similar way that we did our if statements up here. We can do comparisons built into this so that we can do the same sort of thing. Basically this entire thing, but a little bit faster. Now, finally, we have repeat until loops. These are probably the least used loops out of all of these. Will literally be repeat, and then we give it what to repeat. So we're going to print a, and we're also going to print a star with it. That's just going to print a star aside the number that we're printing right here, and a is a local variable assigned to 0. So every time that this loops, it's going to give us the index that we're on, so whatever number a is, along with a star right next to it. And we're just going to make a go up by 2 this time, and we're going to say until a is either greater than or equal to 10. So when it hits 10, that means it's going to stop. If we save this and run it, we're going to see we have 0, 2, 4, 6, 8, because we're going up by 2s each time, and it has our star next to it. We are looking at functions. These are essentially little code blocks that we can call whenever we want. So imagine if a bunch of different like script files, like Lua files that you have scattered all throughout your project, and you're going to just call each one individually. It's like as if you're doing that. You can also feed conditions into it and get information back from it after doing some like calculation or something to figure out some other, like to make another variable. When you make your function, it can either be a local or global variable. So make sure to either assign it as such, and if you don't have local, remember everything by default is global. We just have to give it a function name and then have 2 different conditions. You can have as many conditions as you want in reality. So we want to go ahead and set up what we want to do. And when we have conditions, we can also assign them to variables. They are variables by default, but we can also assign them to different ones if we want to. I don't know, maybe it's going to help us organize it better. Maybe it's going to help us understand what's going on better. But either way, it's something we can do, so I figured I'd show it off to you. We're going to do a for loop. Once again, we can do a underscore for that first variable since we don't need that number. And we're just going to have this loop 10 times. And instead of printing the number this time, we're actually going to print some other stuff. So a print command can actually do a lot more than what you'd expect normally. So it can't just print text, it can also print variables, and you can concatenate, which is what it's called, or concat, 2 different strings and variables together. So what we can do is we can type in string : space, and then outside of the parentheses do ... and then type in our variable. And then we can do ... again. And then to do an enter, like a new line, you just do /n, and then you type in what you want. So we're going to do Boolean, and then we're going to do : space. And I did no spaces before and after the /n because normally if you press enter or like have a new tab or new line, you don't usually just have a space right after you do that or right before you do that. So that's why it's, smart to not have spaces after that. But also have spaces here, otherwise there's not going to be a space before the actual variable. So then we can do dot dot again, and we can do bool. Now, if we were to run this right now, first we have to call it. So we're going to say call function. And to call it, all you have to do is type in the function name, and then parentheses, and if it has conditions, you put the conditions in here. So we're going to put in, this is my string for the string, and then for the boolean, we're going to put in false. Now, if we were to print this, we're going to see it does not want to. For one, I actually forgot to close my for loop. So if I look right here, we can see there's not an end for for. So now we can end that real quick. So if we run it, we can see it does not want to print a boolean, because booleans and numbers need to be converted into strings before actually being able to print. So what we have to do is, instead of just saying bool, we can say to string bool, just like how I showed you earlier in this video, to try to convert the table into a string. You can do that to string function, but only to like booleans and numbers when we're trying to do an example of like putting it into a string, like concatenate it into a string. And I do want to point out the concatenation is not just reserved for print functions. It can also be for anything that needs a string to actually be visible and read. So now if we were to run this with that corrected to string on the boolean, if we run it, we can see it prints just like how we'd expect. All right, just a few more things for functions. We just want to bring up first that we can do local and then a function to make it a local variable of sorts. We can call this one my func, and we're not going to pass through anything. We're going to actually give it table, and that's going to be it. And we can give this local so that if function is inside of a function or a for loop or an if statement, then it will be local only to that area and it cannot be called anywhere else. But by default, if you just did this, it gave it a capital letter at the very beginning, it would be fine because everything by default is global, but you have to make it local. So just like before, how I showed you with that for loop, you can loop through a table and get the contents of that table. So if we come back up to here to our for loops and just copy this actually, we're going to bring it down to this new function and just paste it as is. I'm going to get rid of this and we're going to replace it with my func pass through I. And now this is going to just replay this function, but with the new information. It will still finish the previous loops, and then it will get to this. So it's going to loop through the table first. It's going to find that first table. It's going to print the contents, and then when it gets to the new table inside of that table, it's going to reactivate the function and finish it out, getting rid of everything from that table. So now all we have to do is just print the function itself. And remember, we can just type in the name of the function and then pass something through. So we're going to pass through the table variable, which is our table that we've been using. Save this now, and when we run this, we're going to see it's going to actually give us everything that was inside of all of those tables. We have also table, and we have still table, and we have true, that boolean at the very end. And there we go. You have a function that will literally give you any contents of any table, no matter how many nests of tables are inside of it, which you would not be surprised to hear that is actually a very common thing that you need to do. But real quick, there is something else we can do. Imagine that you were doing some interesting stuff inside this function, like you were changing table in some way or doing some arithmetic to something, and you wanted to make this function actually return something. What we can do is type in return, and then give it something to return. So we'll just type in return table. And down here, when we call it, we can just turn this into a variable calling. So we're going to call this new table, and we're going to make it equals to that function. So when that function finishes running, it's going to give the output of table. So now new table is assigned to the variable table as a separate thing, as another reference, just like earlier. And what we're doing here is passing through the variable. All right, now we have one final thing that I want to show you, and that's going to be your homework. Let's go ahead and come up here to view and make word wrap on so we can see everything. Your homework today is to create a script that tells a story in the console. This can be any length story, it can be about anything that you really want. Just tell some kind of story. Make sure that you call the names as a variable and concatenate the string in the print each time, just like how I showed you earlier. Watch this video as many times as you need to fully understand what we're talking about here. And not only have the names be variables, but also run it in a function or a group of functions. You can figure out what that means and figure out the best ways to do that all on your own. And once you've finished, go ahead and share the code in the Discord. And on the stream, be the week after this, so not today's stream, but next week's stream, I'll be going over some of the things you guys have coded. Only doing it then, not today, because that's a little bit too short of a notice for some people. So definitely next week, hop into a stream next week at 7:30 EST and check out me reacting to your stories. Can't wait to see what you guys make, and I hope you guys have a great one. If you want to see this document, the final document, go ahead and find it down in the description. There's a link to the GitHub where you can download this, run this in your own DaVinci Resolve, just like how I showed you, and you can test things out for yourself. Just like I said, next video about this is going to be us making a script from scratch, starting out with just getting the functionality going. Next week is going to be about actually starting off building our own macro from scratch. So if you're curious about that, check that out, and I'm happy to have you there. If you didn't know, I've made some really cool scripts in the past. You can check out Anim Utility right over here, and you can check out Marker Trimmer right over here. Both of these are fantastic scripts that I've made. One of them actually adds animations to any control in DaVinci Resolve Fusion, and the other one actually trims up your timeline around your markers. And there may be a new OBS update coming to actually make that even easier to do. So I'll see you in the next one. Check out one of these videos, and I'll see you there.